All designs are created from entities. Here is the basic structure for an entity declaration. The keyword entity begins the entity statement. The name of the entity follows the keyword. The line ends with the keyword is. An entity consists of two sections, the generic declarations and the port declarations. Generic declarations are used to pass information into the model. The port declaration section describes the inputs and outputs to the entity. There are several ways to close the entity depending on what your preference is and what version of VHDL you are trying to support. The port declaration is used to declare the I/O to your entity and occurs within the entity declaration after the generic declaration. Similar to the generic declaration, the port declaration starts with the keyword port and then, within parentheses, lists all of the I/O. It ends with a semicolon. The structure for a port declaration goes class, object name, colon, mode, and then type. The class is most always signal, though it doesn't have to be, so you almost never see the word signal actually appear in a port declaration. The object name is the name of the I/O port. In this example, the object names are clock, clear, and queue. Since clock and clear are of the same type, they are declared together, separated by a comma. The mode is the direction of the port. In VHDL, the keywords for directions are in for input, out for output, in out for bidirectional, and buffer for an output with internal feedback. Typically, input signals can only be read from and not written to. Outputs can only be written to, not read from. In-outs must be used as both inputs and outputs. With buffers, physically in the device you will have an output pin, but you'll be allowed to read from it as well. Use care when using buffers, as there are restrictions on them when connecting them to other design blocks hierarchically. Personally, I stick with in, out, and in, out. And lastly, the type is a data type that defines the type or values that can be held by your I/O. Like the generic declaration, the semicolon is used as a separator, and the last port declared is not followed by a semicolon, as you can see after the word bit for the Q port. Generics are values that could be passed into an entity at compilation time. We use them to make our entities parameterizable when designing hierarchically. The generic declaration is contained inside of the entity declaration. We use the keyword generic and within parentheses list the generics. The format for a generic declaration goes class, object name, type, and initial value. The class signifies what can be done to the generic. Generics are almost always constants, and the keyword constant is usually left out. The object name is the name of the generic that will be used within your model. The type is the data type, which specifies the values that your generic can hold. Finally, the initial value is optional. As you can see in the example, the generic declaration is itself considered a statement and ends with a semicolon. Within the parentheses, the generics are listed with semicolons separating each one. Since the semicolon is used to separate the list, there is no semicolon after the last generic, as you can see after the word up. Also notice you can declare multiple generics in one line if they are the same type and initial value by using the comma. Thus, TPLH and TPHL are both generics of type time initialized to 5 nanoseconds, and TPHZ and TPLZ are both generics of time initialized to 3